Let him answer. Come, Sharif, which one? Log 4x. So we are, for part A, this is what we'll have. Log base 2 4x equals to, you leave it as 1. Log base 2 2 minus, minus what? Huh? Log base 2 what? Log base 2 4. Okay, so what do we do next? Where is your work? Can't find. Did you do? Okay, then continue. Where did the half come from? And where did my log base 2 4 disappear to? What? Did you do your work? So, how do you arrive at half? Change which one? Change what? 4 becomes 2 to the power 2. Okay? Like this? Okay, Sharif, do you know how to continue? Do you know how she got half log base 2x? Okay, what do we do next? What can we do next? Annabelle? Can you help him? Two log 4x. You multiply everything by 2. Okay. 2 log base 2 4x equals to 2 log base 2 2 minus log base 2x. Is this what you want? And then what happens? How to remove the log 2? Bring this 2 up here, is it? Then this one also bring up here? So am I right to say that this gives us log base 2 4x squared? Oh, okay. Log base 2 2 squared minus log base 2 x. Yes? Sharif, can you continue? Cancel the log 2, like that. Huh? Yes or no? Then how? Log base 2 4 over x. Log base 2 16x squared. All of you agree so far? What do we do now? What is the next step then? Say again? Okay, 16x squared equals to 4 over x. Yes, because here we are not dividing by log. Please don't come and tell me that we divide by log 2 on both sides. No, we are saying that since log base 2 something equals to log base 2 something, then the two somethings must be the same, right? Ah, okay. So that's what we have. Yes. Hang on. Here we have 16x cubed equals to 4. X cubed equals to 1 over 4. X equals to plus minus, sorry, no plus minus. Cube root of 1 over 4. Okay, there you get the answer. Yes, Darius, what's your question? How do you remove? How? What do you mean by remove? Cancel, is it? But when you say cancel, you are meaning divide, is it? Then what does it mean by cancel?
For the highlighted side, remove it, right? But then why can't you remove it like that? Why must you do until the quotient law then you remove it?
You mean over in this blue color one, why cannot just remove like that, is it? Is this your question? Okay, class, look up. In the blue color rectangle, in the blue color box, why is it that I cannot simply cancel, therefore leaving me with 16x squared equals to 4 minus x? Why can't I do that? Okay, log is a function, so?
So it's not like number like sin, cosine, all this, you cannot just divide them away. So you must do the quotient law.
Okay, so he mentioned one keyword. You cannot divide them away. Because whenever you do things like this, cancel, what exactly are you doing? There is no cancellation in mathematics. There is only dividing throughout in your fractions, right? You divide throughout by 5, for example. You multiply throughout by half, for example. So that gives you the impression that you are cancelling away things that are the same. Okay? So when you try to use the same logic over here, oh, they are the same, so let's cancel them. You are trying to tell me that you are dividing. Are you saying that therefore this is log base 2 multiplied by 4x squared equals to log base 2 multiplied by 2 squared minus log base 2 multiplied by x? Is there a multiplication? No, there isn't. This is a function. We are not doing multiplication. If today this log base 2 over here is written as, for example, y, then there's another y over here, there's another y over here. Yeah, okay, fine. You can divide by y. In other words, you can cancel all the y's, provided y is not equal to 0, because you can't divide by 0. Understand? Understand, Darius? Now next.
So can we say the answer must be what again?
In this case, since it is exact, you can leave it as exact. Okay, I know your answer key gave it as decimal, 0.630.
Actually, the number is like the best case, very long one.
3SF is fine lah. Okay, now moving on. Part B. Okay, again I need help. Daniel, come help me again. Two. The 2 is outside the fraction, is it? Does it make a difference? But he likes it that way, okay, I give it to him. Okay, then? Base 2x equals to 3. Okay, then? Equals to? Y. Okay, I do the substitution for you. 2 log base 2, 2 over y minus 2y equals to 3. No more. Oh, okay, yeah, then? Okay, so 2 log base 2 minus 2y squared minus 3y equals to 0. Oh, this is simply 1, okay, so this becomes 2. Okay, so for those who requested for part B, from here on, can you continue yourself? Yes? Why cannot, is it? Didn't say cannot, huh? He wants to change, instead of log base x2, are you suggesting to change for the other one? Okay, let's see what happens. So I'm not erasing what Daniel suggested. We're not going to have 2 log base x2 minus, what should I put in over here? Base x. What about the square? Okay, so actually, he's actually saying that, we bring the 2 down first, log base 2x equals to 3, right? Then after that, he wants to change this to base x, so that it will be the same as this over here. 2 log base x, 2 minus 2 log base x, 2 over log base x. Hey, the top one should be x, 2 equals to 3, yes? Okay, no problem. This will again be equal to 1. So we have 2 log base x 2 minus 2 over log base x 2 equals to 3. Let y equals to log base x 2. Then now you will end up with 2y minus 2 over y minus 3 equals to 0. 2y squared minus 2 minus 3y equals to 0. Now you get a quadratic equation which is quite similar but not the same as the previous one. You continue to solve it using your quadratic methods. You substitute them back inside here. You will still get the same values of x. So it is not a question of why cannot. It should be, can we do this? So yes, you can. All right. Part C. No, your recess is soon. Okay, part C. Ying Zheng, can you help us? Okay, do you all see why it became an 8 over here? Okay, good. What's the next step, Ying Zheng? Like this? Wow, I thought you were trying to skip step. Okay, next. So since you combine these two already, why don't you combine these two? Continue. Right? Okay, what next? Well, what did you say? Taking log base 2 on both sides. Did you say taking? We already have log, Oh, okay. So equals to 16x squared. Who needs explanation for this step? Then from here, this is quadratic. You can do it by yourself, yes?
Yeah, why is it 16x squared?
So what is what? Cannot square root both sides, right?
1 minus x squared equals to 16x squared.
Cannot square root, right?
Can we square root both sides? If you introduce the square root, then what else must you do?
Plus minus.
Yeah, then you can.
Okay.
Now part D.
This one will be like this, right? From here, then you.
No, you didn't do it correctly. David, part D. Square root of 16 is not 8. Log base 5. 50, okay. The 4 is outside, okay. Plus. Okay. Now over here in the denominator, log base 5, 25 gives us 2. Cancel because we are actually dividing. This gives us 2. These two, they have a base 5 already. Bring the 2 up here. So we can combine log base 5, 2x plus 4 times 25. On this side, we have bring the 2 up. Log base 5, 50 times x squared. So compare whatever is inside the log. So same thing. Now for the last part. Plus 1. Okay. Why plus 1? Okay. Did you say log base 4? 64? 64. Can we evaluate this one already? Instead of 64, we write here as 4 to the power of 3, which is actually 3. Okay, let's skip a few steps over here. This is simply 3. Okay, what next? Base 4. 5x plus 1. I prefer to write it as fractional indices. Log base 4, 2. Log base 4, 4 equals to x minus 2, then the plus 3. Or do you prefer to have it as a base earlier on, base 4? So that you can combine, is it? Oh, okay. So I shouldn't have done this. So it should have been log base 4, 64. So you multiply by 64? Okay, then? Okay, this one is equals to half. So let's put it over here. Yeah, you go and watch the video. So you were saying the denominator is half, right? Okay, so let's put the 2 over here. Because you divide by half, it's actually multiplying by 2. Okay, so now we can combine. Okay, so the next step, you see the 2 over here, we can bring it up to the power. So it becomes log base 4 5x plus 1 plus log base 4 4. Yeah, log base 4 x minus 2 64. So this one we can combine again. Then we compare. And then you check whether all answers for x are acceptable. You will still get the same answer, right? Yeah, so different approaches. All your laws of logarithms they all hold true. Okay, next. Question 56. B, E. Any more? Okay, let's start with part A. Anybody needs help for part A? Part C? C? D? F? Okay. In view of the lack of time, I will do part D. For part D, 5 power 2x plus 3 minus 4, 3x minus 3 equals to 0. One equation, how many unknowns? One unknown. Where is the unknown? It's in the power. Therefore, you must either compare the bases, then you make the bases the same, then compare the power, or use logarithm. Okay? So right now, is there any way they can make the bases the same?
No.
Cannot. Definitely need to use logarithm already. Okay? But your laws of indices are going to be very useful over here because for this style of question, question 56, try to isolate a to the power x. Okay, you see, I've got a lot of 2x plus 3 x minus 3, negative x plus 2x minus 5, all sorts of things. I want you to be able to isolate a constant to the power x out. So what do I mean over here? This is the same as 5 to the power 2x times 5 to the power 3. Yes? Okay, then minus 4 times of 3 to the power x divided by 3 to the power 3 equals to 0. Am I right? Okay, so you see, I am always trying to make this come out. Here I've got 5 power 2x. Is it the same as 5 power x? Is 5 power 2x the same as 5 power x? Obviously not lah. So how do I make the 5 power x appear? Okay, so this is 5 power 2, then power x. Right? Then multiply by 125 minus 4 divided by 27. 3 power x equals to 0. Okay? So 5 squared. How much is 5 squared? 25. 25 power x times 125 minus 3 power x 4 over 27 equals to 0. Okay? So right now I have something power x times something minus something power x again. But like I said, I always want to try and isolate just a constant to power x. Now I got two terms with a power x. I want to try and combine them together. Move all these to this side. Let's see what happens. So 125 times 25 power x equals to 4 over 27, 3 power x. Move the x over. So you're saying divide by 3x on both sides. 25 power x divided by 3 power x equals to 4 over 27. Divide by 125 on both sides. Times 1 over 125. Okay? So now on my left hand side, I've got 25 over 3 power x equals to 4 over 27 times 125. So here I've got number power unknown equals to another number. Cancel or not? How do we solve this? What do we do? Since the bases very difficult to be the same, you try and error for very long, you also may not be able to get it. Take log on both sides, okay? Log 25 over 3 power x equals to log 4 over 27 125. So this is the crucial step where you take log on both sides. How does that help me find x? What shall I do with this x over here?
Move forward.
Okay, move it over here. X log 25 over 3 log 4 over 27 125. Yes?
And from the 25 over 3 power x equal to, can change to like log form, but not take.
Change this to log form. Like this.
No, like log 4 over, I think, log base 25 over 3.
Okay. So you are saying that this is simply x equals to log log 25 over 3 equals to 4 over, no, what am I writing? 4 over 27 125. Is that it? Is that what I'm saying? Then how to evaluate? Then you change base, okay? So you get log 4 over 27 125 divided by log 25 over 3. Right? Can be done. But let's see what happens if I continue with this. Log 4 over 27 125 divided by log 25 over 3. Aren't they the same? Same, right? So different methods, you arrive at the same answer if you do it correctly. A 3SF. Okay? Evaluate all your logarithms and logs. Yes.
For Shah method, he made the exponential form.
Yeah, he changed it to the logarithm form.
Log form.
Yeah. Okay, from exponential to log form. The last few questions, I'll be posting them online again. There are different types of questions. I'm quite sure one of these will come out, either 59 or 60. One of these types of question will come out.